Hello everyone, welcome to our YouTube channel Academics. In this video, we are going to discuss about UCB algorithm, where UCB algorithm is the most popular algorithm in RL, which is a method used for solving multi-armed bandit problems. As I already said you that in achieving sublinear regret, we are for balancing these, we are going to use these techniques like UCB bounds and Townsend samplings for achieving sublinear regret. I have said you already in the previous videos. If you didn't watch it, please go check and watch it. Otherwise, you won't understand. So what UCB says is definition. Full form of UCB is upper confidence bound algorithm, where UCB follows the principle of optimism in the face of uncertainty, which means that if we are uncertain about an action, then we should optimistically assume that it is a correct action. So what we do in UCB means first we need to estimate the expected reward for each action, or we need to calculate the actual value of an action, and then we need to calculate the upper bound values, and then we need to update the we need to update the estimated values as well as number of times the action is selected. We need to update them, and again follow the same process until it reaches end. So let's discuss about the algorithm. So here it is nothing but same. It balances between exploration and exploitation by assigning the UCB values, and it is the most widely used technique. So then in this initialization, we need to initialize first a Q of A. Q of A means nothing but estimated value, means we have to predict or estimate that by doing this action we are going to achieve this reward or this much value we are going to expect. We need to first only we have to initialize it, and we also need to initialize that how many times that the action is selected in a given period of time, and in the we have to initialize the time step to t equals to 1. Then for each action you have to calculate the UCB values. So for calculating the UCB value of an action, here it is a formula. UCB of A equals to Q of A plus C into square root of logarithm T by N of A, where Q of A is an exploitation term and square root of logarithm T by N of A is an exploration term, where C is the constant term. So Q of A is nothing but the estimated value of an action A the given time period T, where logarithm of T is natural logarithm of T, where N of A is number of times the action is selected. And we need to calculate the upper bound values for each action, and we have to select, after calculating all the actions, we need to select the we need to select the action which is having highest upper bound value. After selecting the upper bound value, we need to again calculate the q star A means updated value of estimated value, and n star A. So this is the formula you need to remember, and again you need to repeat the steps 2 and 3. Here you have the diagrams of confidence interval level. I'll show you clearly. Yeah. So here you can see that this bracket indicates the confidence level, confidence interval. The bracket above the confidence interval says that it is the upper bound value, and here lower the bracket indicates lower bound. Here confidence interval is nothing but it is so confident that the actual value, the Q of A, what the actual value of an action to be selected will be lying in this region. So that it is so much confident that it will obviously lie in this region only. That indicates the confidence interval. So if the confidence interval level is low, then it becomes very certain that the actual value of action A is our estimated value. Then I've already said you that principle of it follows the principle of optimism and all. And here see, let us see these. Let us assume that these are all our actions A, B, C, D. Actual values Q of A, estimated actual value of action A, estimated actual value of B, estimated actual value of C and D. So it is having the highest upper bound value. It is having low. It is having low. Lesser. These are having lesser. So as I said you, here upper bound value of action A is inversely proportional to number of actions, number of times the action is selected is inversely proportional to UCB of A. UCB means upper confidence bound value of an action A. If it is UCB value of an action A is higher, then the number of times the action is selected is lower. So we have to only select the values which is having the highest upper bound value. So in this, okay, yeah, in this diagram, these are few actions or estimated values of an action A, B, C, D. So comparing all this, it is having the highest upper bound value. So we are selecting this action. And then after selecting this action, it's obviously when we select it, its upper bound value decreases, and then its confidence level also decreases. So in this video again, see, you can see here it is decreased, and upper bound value of B is even the confidence level is small when compared to other, but it is having the highest upper bound value. So we are choosing that action, and we are again updating those estimated values for our plan or like stated policy. As I already said, you see here in this diagram, Q of A is selected because it's having highest upper bound, and here Q of B is selected, and then it says that number of times an application increases, then UCB values decreases, which leads to exploitation of other actions. And then the choice of constancy. Here constancy, you have get it in this formula where it is here you can see the constant term determines the balance between exploitation and exploitation trade-off. So if the value of C values are more, then it leads to exploration. If the values are less, then it leads to exploitation. You can see here where it is. Okay, C leads to more exploration. Higher values of C leads to more exploitation, whereas lower values of C favor exploitation. Then the value of C depends on the specific problem and can be adjusted to the strike of desired exploration and exploitation balance. Then next, so UCB, so the agent, what he does is he interacts with the environment and gathers all the information, like by taking which action or by selecting which action, we are getting which kind of reward or which kind of that we are getting. He collects all the information, and based on that information he tries to or makes decisions. The decisions are made by that information, and using this algorithm the balance is maintained between exploration and exploitation to achieve the sublinear regret. So we are basically using this algorithm to achieve sublinear regret. And here we can see UCB algorithm achieves sublinear regret, where means the regret total optimum reward minus. Here the regret formula they have written total optimal reward. As you all know, the regret formula, it grows slower than the linear. Means you have this, or you have already seen this step or sentence in the video of achieving sublinear regret, and that's it for this UCB algorithm, where UCB means upper confidence bound algorithm. And that's it for this video. Thank you.